on assignment 8.5, which is on z-test for proportion. It's on page 434. We're going to do traditional methods. We're going to follow the same 5 steps we've been following. Here's the problem. A recent survey found that 64.7% of the population own their homes. In a random sample of 150 heads of households, so n equals 150 on this one, 150 households, 92 responded that they own their own home. So x equal 92. What's that? Yes, you do. Yep. So p hat equals 92 out of 150. That's your sample proportion. If that translates to a nice decimal, you can change it to a decimal if you want, or leave it as a fraction. At the 0.01 level of significance, does that indicate a difference from the national proportion? So what's alpha? Yep. Guys, if you're out there talking, it's really hard to hear that video when there's talking in the background, so please stop talking and pay attention. Alpha is 0.01. Okay? So we're going to do our 5 steps again. We're going to start by writing the null and the alternative. Now we're not going to, something's going to change here because we're not trying to make a prediction about a mean or an average. Now we're making a prediction about a proportion. And it says, a recent survey found that 64.7% of the population own their homes. The question is at the 0.01 level of significance, does that indicate a difference from the national proportion? So they're saying, is there a difference? Is p not equal to 0.647? I think that's what they're claiming. You kind of have to read carefully, and it's hard to tell. But it seems to be meaning that they're claiming that the population proportion is not 0.647. The null would be that the population proportion equals 0.647. So it's got an equal sign. Is it two-tailed or one-tailed? Two-tailed. Okay? So for part B, we're going to find our critical values. It's going to be two-tailed. We're going back to using z-scores again. There's going to be a critical value over here and a critical value over here. So which chart do you think we'll use? Go back to your z-chart again. Okay? Alpha is 0.01. With the z-chart, if it's a two-tailed, you have to divide by 2. So if alpha is 0.01, alpha divided by 2, take 0.01 divided by 2, you get 0.005. So each tail area is 0.005. And again, what this alpha tells us is that if the null is true, we still have a 1% chance that we're going to reject it when we shouldn't. So we have a 1% chance of making what's called a type 1 error. If you take 0.5 minus 0.005, you get 0.495 in these two areas. Now you go to your z-chart, look up 0.4950, look over and look up. What z-score does that give us? 2.58. 2.58. Others agree with that or not? Okay, good. So our left critical value is negative 2.58. Our right critical value is z equals positive 2.58. Any questions about that? Part C, we're going to find our test value. This is where we're going to use our z formula for proportions. So z equals p hat, our sample proportion, which is 92 out of 150, minus p, which is 0.647, divided by the square root of p times q times n. P is 0.647. Divided by n, yes. Yeah. Thank you. Times. Now, how am I going to find q if I know p? It's 1 minus the 0.647. P is 0.647. Q would be 1 minus that, so that'd be 0.353. Yep. Divided by n. What's n in this case? Right, 150 people. 150 households. Heads of households. You have to make sure you put parentheses around that, so you take the square root of that whole thing. Type that in. Anyone tell me what that comes out to? Negative -0.948. So that what that's telling me is that the sample proportion of 92 over 150 is about, it's negative -0.948 standard errors below the mean. So it falls about right in there. Negative -0.948. Anyone else get negative -0.948?
Negative 8.6.
Negative
Negative
0.86?
Negative 0.86.
Oh, yeah. 0.86.
Okay. We can double check that later with the answer book, but it's a matter of typing it in right. Either way, it's going to fall in this white region. So do we say reject or not reject the null? Do not reject. Good. Yep. So D is do not reject the null. So what that's saying is that 92 over 150, that proportion is close enough to 0.647 that we can't reject that the true proportion is 0.647. We're saying, what is 92 divided by 150, by the way? Let's just give an estimate on that. Point what?
0.613 repeating.
0.613 repeating. So 0.613 is close enough to 0.647 that the population proportion very well could be 0.647. Okay? The difference between these is probably just due to sampling error. All right? Because 0.613 is only 0.86 of a standard error below the mean. So it's close enough to the mean that we can't reject the null. If we can't reject the null, that means we think the null is probably true. We're not proving anything, but we think this is probably true. So what's that mean about our claim down here? Not enough evidence to support it, right? So for part E, there is not enough evidence to support the claim that the proportion differs or is not equal to from 64.7%. Something like that. There's not enough evidence to support this claim. Now, have we proved that that claim's not true? No. But there's not enough evidence to support it, and that's all we can really say. That's good.